We're now going to look at the product rule for three functions. That is when we have an equation where there are three functions being multiplied together. So that would look something like this. Say that we have the equation y is equal to f times g times h. Then what our product rule would now look like, we would have y prime being equal to, in the first term, we will differentiate the first function. So it'll be f prime times g times h. So the first function will be differentiated, and the next two functions will stay as is. Then we will have the sum. We'll keep the first function as is. We will differentiate the second function and keep the third function as is. Plus, we'll now keep the first two functions as is and differentiate the third function. So a good idea of the product rule is that in every term, a different function will be differentiated. In the first term, the first function will be differentiated. In the second term, the second function will be differentiated. And in the third term, the third function will be differentiated. Now let's apply this to an example for it to make better sense. Say that we are given y is equal to, and our first function is x plus 1 to the power of 10. The second function is 2x plus 3 to the power of 11. And the third function is 4 minus x to the power of 12. Now, before we start, we need to be able to understand what our three functions are, and it's actually best if we label them. So it's a lot easier for us going forward. So let's label this first bracket as f. So that bracket represents the function f. The second bracket will represent the function g, and the third bracket will represent the function h. Now this makes it a lot easier for you to understand how to apply your product rule. So let's start off. We're going to say y prime is equal to, now remember, in your first term, you are differentiating your first function. So to differentiate this function, we're going to take the exponent and multiply it with the coefficient. If there is no coefficient shown in front of the bracket, we know that it is 1. So we're going to have 10 times 1, which is 10. We'll keep this bracket as is, and we are going to minus 1 from the exponent. So the exponent now becomes 9. Now, I'm actually going to cover the chain rule in the next video, but we do need to apply it here as well. The chain rule tells us that once we've differentiated outside the bracket, we're now going to differentiate inside the bracket. Inside the bracket, we've got x plus 1, the derivative of x is 1, the derivative of 1 is 0. So there's no need for us to write out the 1. So I'm just going to leave this as is. Now remember, for the product rule, in your first term, you differentiate f and you keep the next two functions as is. So next to that, we're going to have the bracket with 2x plus 3 to the power of 11 times the bracket of 4 minus x to the power of 12. Now this is our first term. In our second term, we're now going to differentiate g. So we can keep the first bracket as is, x plus 1 to the power of 10. Now differentiating the second bracket, we're going to have 11 times the coefficient, which is 1. 11 times 1 is 11, and we are going to minus 1 from the exponent. So the exponent is now 10. At the same time, we now need to apply the chain rule. So differentiating within this bracket, the derivative of 2x is 2. The derivative of 3 is 0, so that falls away. Now we've differentiated g. We're now going to go on to the third bracket and keep the third bracket as is. So this was our second term where we've differentiated the second function. We've differentiated g. For the third term, it's f times g times h prime. So we are now going to keep the first two functions as is. So we'll have x plus 1 to the power of 10 times 2x plus 3 to the power of 11. And we will now differentiate the third function. So we're going to take 12 and multiply by the coefficient. 12 times 1 is 12. And we are going to minus 1 from the exponent. So our exponent is now 11. So for this function as well, we need to apply the chain rule. We've differentiated outside the bracket. We are now going to differentiate inside the bracket. The derivative of 4 is 0. The derivative of negative x is negative 1. So just remember that for these two functions, that is where the chain rule was applied. Now, once you've applied your product rule, if you are able to simplify, then you should. So if you look at your first term, if there are any coefficients that can be multiplied together, we should multiply them. There isn't anything, so our first term will actually stay as is. In our second term, however, we've got this 11 and 2 that can be multiplied together. So that's going to become 22. And we now have our brackets. And in the third term, we've got 12 times negative 1. So that's going to be negative 12. So we actually don't have to put the plus here. We can put the minus. So it's going to be minus 12. Let me write this underneath. It's going to be minus 12 and our brackets. So that is going to be our final answer. So just to run through the product rule for three functions once more, you need to remember that you've got three functions being multiplied with each other. So they can represent f, g, and h. If there are three functions, once you differentiate, they're going to be three separate terms. In the first term, the first function is differentiated. That is where we have f prime, gh. In the second term, the second function is differentiated. That is where we have f, g prime, h. And in the third term, the third function is differentiated. That is where we have f, g, h prime. In the next video, I will be discussing the chain rule and looking at a few examples where it can be applied.